All right, this is section 4.3, right triangle trigonometry. So we will start with a little refresher of the three basic trig functions from geometry. That's SOHCAHTOA. And we spent a day on this now, so I'm not going to go into it in this video, but there's another video of the basic trig functions if you forgot. And then you did that. All right, so the trig functions, there are actually 6. I know you've only learned about 3, but there are 6. So based on our triangle, right, across from the right angle is still our hypotenuse. I'm going to call it HYP for short. Across from the angle we care about, that is still our opposite. I'll call it OPP. And next to our angle, that's not the hypotenuse, that is our adjacent, or ADJ. That's nothing new. Sine, cosine, tangent, also nothing new. Sine is opposite over hypotenuse. Remember SOHCAHTOA. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. That's all from geometry. But now we are going to talk about 3 others. And they line up this way. We'll usually write them this way too. Sine is next to CSC. CSC is cosecant. And they are related because cosecant is just the reciprocal of sine, which is hypotenuse over opposite. SEC lines up with cosine, that is the secant. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. And COT is actually cotangent. It lines up with tangent because it's the reciprocal of tangent, which is just adjacent over opposite. So there are 6 trig functions. So let's find the values of all 6 trig functions for this angle theta. Well, the first thing we need to do is find this missing side. It's a leg, so we'll do 20 squared plus x squared equals 29 squared. And 20 squared gives me 400. 29 squared is 841. Subtract our 400. X squared is 441. Square root of both sides. And our value of x is 21. Remember, just the positive one because we don't have negative sides. So this side is 21. Then I'm going to label my 3 sides. Opposite, adjacent, hypotenuse. Well, across from the right angle, that's always my hypotenuse. Across from my angle that I look at is the opposite. Third side is the adjacent. So we'll start with the basic 3 we know. Sine of theta is opposite over hypotenuse, so 21 over 29. Cosine of theta, adjacent over hypotenuse, so 20 over 29. And tangent of theta, opposite over adjacent, 21 over 20. Remember that you will simplify these if you can. These ones just happen to not be simplifiable. Sine lines up with cosecant of theta, and all we do is flip it over, so it's 29 over 21. Secant lines up with cosine. It is 29 over 20. And tangent lines up with cotangent. It is 20 over 21. Notice that we don't turn the secant and the cosecant, or the tangent, into a mixed number. Always leave them as improper fractions. It makes your life way easier in the long run, and you'll never see it as a mixed number. So we have a triangle, ABC. It has legs of 6 and 3. We'll evaluate the 6 trig functions for angle B, where B is the larger acute angle. So first we'll start off with a triangle, sides of 6 and 3. I can find that missing side, right? 3 squared plus 6 squared equals x squared. I get 9 plus 36. We have 45 equals x squared. Square root of 45, I know I can do 9 times 5. So x is 3 square root 5. There's my hypotenuse. Then I have to decide which angle is B. It says it's the larger acute angle. So B is not the right angle. Larger angles are always across from larger sides. So across from the 6, this is angle B. Now we can label our sides. Our opposite is the 6 because we just used it to find across from it. The hypotenuse is 3 square root 5, and my adjacent is 3. So now we'll take the sine of B, so we know it's named B, is opposite over hypotenuse, so 6 over 3 square root 5. Well, the 6 and the 3 simplify to a 2 and a 1. So I have 2 over the square root of 5, but we don't leave square roots in the denominator, so we'll multiply it on the top and bottom, and we get 2 square root 5 over 5. There's our sine. Let's actually go straight into our cosecant right away. Because remember, cosecant is the reciprocal of sine. To make your life easier, either start at the very beginning or before you rationalize the denominator for your reciprocal. Because this way it's square root of 5 over 2. If you didn't start there, so let's say I started here. 5 over 2 square root 5. I have to rationalize my denominator. I get 5 square root 5 over 10. Now I have to simplify the 5 and the 10. It becomes the square root of 5 over 2, which is what we had in a much shorter way. Now for the cosine of angle B. Cosine's adjacent over hypotenuse, so 3 over 3 square root 5. My 3's cancel, leaving me 1 over 1 square root 5. Now I rationalize my denominator. So we get the square root of 5 over 5. Cosine lines up with secant. Secant is the reciprocal of cosine. Again, go to this spot before you rationalized. Square root of 5 over 1, or just the square root of 5. And then tangent of angle B is opposite over adjacent, which is 6 over 3, which simplifies to just 2. Tangent lines up with cotangent. Cotangent's the reciprocal. Remember that the reciprocal of a whole number is just 1 over that number. So our cotangent is 1/2. All right, now we're going to get really crazy. Theta is an acute angle in a right triangle, satisfying the given condition. Evaluate the remaining trig functions. I recommend we draw a picture. Doesn't matter exactly how you draw the picture. We got a right angle, and one of these is called theta. It tells us the cosecant is 4 over 3. Remember, cosecant lines up with sine, so we actually can go straight to the sine of theta is the reciprocal, so it's 3 over 4. Well, sine is opposite over hypotenuse, so our opposite is 3. Our hypotenuse is 4. Now we can find that missing side. X squared plus 3 squared equals 4 squared. So x squared plus 9 equals 16. Subtract my 9. X squared equals 7. Square root x is the square root of 7. There we go. Remember that 3 was our opposite, 4 hypotenuse, square root of 7 is adjacent. So now I know the cosine of theta is adjacent over hypotenuse, so the square root of 7 over 4. I don't need to list the cosecant because we already know it. It was given to us. But I do need to say the secant of theta. The secant is the reciprocal of cosine, so it's 4 over the square root of 7. But we have to rationalize our denominator, so multiply by the square root of 7. We get 4 square root 7 over 7. And then the tangent of theta. The tangent is opposite over adjacent, so I get 3 over the square root of 7. Rationalize my denominator. We have 3 square root 7 over 7. And tangent lines up with cotangent. We take the reciprocal before we rationalize the denominator. So it's the square root of 7 over 3. If you take your reciprocal at the right places, in any given problem, you should only have to rationalize a denominator at most 3 times, unless all the sides have square roots. But most of the time, you'll only have to do it twice. All right, next problem. Theta is an acute angle in a right triangle satisfying these conditions. Let's evaluate the trig functions. So I'll draw myself a triangle. There's theta. The cosine is square root 5 over 3. That's the adjacent over hypotenuse. Well, my hypotenuse, adjacent, opposite. So my adjacent is square root of 5. My hypotenuse is 3. I can find my opposite. Square root of 5 squared plus x squared equals 3 squared. 5 plus x squared equals 9. Subtract my 5. X squared is 4, which means x is 2. My opposite side is 2. So now we go into our 6 trig functions. Well, 5 because we already know one. The sine of theta is opposite over hypotenuse, which is 2 over 3. That lines up with our cosecant of theta, which is just 3 over 2 then. We know the cosine is square root 5 over 3. Cosine lines up with secant. We take the reciprocal, so it's 3 over the square root of 5. Square root in the bottom. Rationalize the denominator. Our secant is 3 square root 5 over 5. And then the tangent of theta. Tangent is opposite over adjacent, so we have 2 over the square root of 5. Rationalize our denominator by multiplying it on up. We have 2 square root 5 over 5. And tangent lines up with the cotangent. If we take the reciprocal before rationalizing, we have the square root of 5 over 2. And there are all of our trig functions. And we got one more of these. It tells me the sine of theta is 3 over 4. So we will draw our triangle. Here's theta, opposite, adjacent, hypotenuse. Sine is opposite over hypotenuse. So my opposite is 3. My hypotenuse is 4. This problem sounds pretty familiar. Because if we take x squared plus 3 squared equals 4 squared, we have x squared plus 9 equals 16. X squared equals 7, so x is the square root of 7. This is the exact same triangle we had 2 problems ago. Same exact triangle. So that means all the answers are exactly the same. We already have the answers. We were given the sine, so that means the cosine is the square root of 7 over 4. The tangent is 3 square root 7 over 7. The cosecant is 4 over 3. The secant is 4 square root 7 over 7. And the cotangent is the square root of 7 over 3. Same exact triangle, same exact trig values. Now we're going to talk about special right triangles, because you should hopefully have heard of these. If we think about a special right triangle for a 45-degree angle, well, 45-degree angle means that this is an isosceles right triangle, which means whatever this one leg is, the other leg is the exact same length. If we do the Pythagorean theorem with this, x squared plus x squared equals c squared, well, that's 2x squared equals c squared. Square root both sides, we have x square root of 2 is c. So there's our hypotenuse. Now we find the 6 trig functions. Well, let's say we're looking at this one. Opposite is that x, hypotenuse, adjacent. So the 6 trig functions, the sine of a 45-degree angle equals opposite over hypotenuse, which is x over x square root 2. My x is canceling, leaving 1 over the square root of 2. I rationalize my denominator, and I get square root of 2 over 2. There's the sine of any 45-degree angle. Let's also look at the cosecant. Well, cosecant is the reciprocal, so the cosecant of 45 degrees, is the square root of 2. All right, cosine of 45 degrees. Adjacent over hypotenuse. My adjacent is x. My hypotenuse is x square root 2. Oh, look, it's exactly the same, which means it's going to become square root 2 over 2. The secant of 45 degrees is the reciprocal, which is going to be the same as the cosecant. And the tangent of 45 degrees is opposite over adjacent, which is x, over x, which is just 1. And the cotangent is the reciprocal of 1, which is still 1. Any 45-degree angle has these same trig values. Now we're going to look at 60 and 30. And when we look at a 60 and 30, we want to think about an equilateral triangle. If I think about an equilateral triangle, every angle is 60, right? And all the sides are the same. So I've got a full side here and here. Those are both x's. If I draw a line right down the middle to create a right angle, I created a 30-degree angle up there. And it's right down the middle, so it cut this side in half. So that is x divided by 2. And now I'm going to redraw this because I don't like x divided by 2. I want to call this just x. So if that's just x, then I multiply by 2, so this side is 2x. That just makes our lives a little bit easier for the next steps. To find this missing side, x squared plus question mark squared equals 2x squared. So x squared plus question mark squared equals 4x squared. Subtract an x squared. My question mark squared is 3x squared. Square root both sides. And the question mark is x square root 3. Which means no matter what x is, I can find all 3 sides now. So we need the 3 trig functions for 30 and 60. Let's start with 60. From 60, my opposite is the x squared root 3. Adjacent is x. Hypotenuse is 2x. So, the sine of 60 degrees is x squared root 3 over 2x. Well, my x's cancel, leaving me square root 3 over 2. My cosecant then of 60 degrees is 2 over the square root of 3, which I will rationalize. And it becomes 2 square root 3 over 3. The cosine of 60 degrees, adjacent over hypotenuse, is x over 2x. When my x's cancel, I get 1/2. The secant of 60 degrees, then, is the reciprocal of 1/2, or just 2. And the tangent of 60 degrees, opposite, which is x square root 3, over adjacent, which is x, we get just the square root of 3. And the cotangent of 60 degrees is the reciprocal, so 1 over the square root of 3. But we rationalize our denominator, turning it into the square root of 3 over 3. There are the trig functions for any 60-degree angle. For 30, we go back up to our picture and we change our side labels. The x is now the opposite. X square root 3 is the adjacent. 2x is still the hypotenuse. So for the sine of 30 degrees, opposite over hypotenuse, x over 2x is 1/2, which means the cosecant of 30 degrees is the reciprocal of 1/2, or just 2. The cosine of 30 degrees is adjacent, which is x square root 3, over hypotenuse, which is 2x. Again, my x's cancel, giving me the square root of 3 over 2. The secant of 30 degrees is the reciprocal of that, which is 2 over the square root of 3. We already rationalized that as the cosecant of the last one. So it'll become 2 square root 3 over 3. And the tangent of 30 degrees is opposite over adjacent, which is x over x square root 3. X is canceled, leaving me 1 over the square root of 3. Multiply that on up, I get the square root of 3 over 3. And my cotangent is the reciprocal. Take the reciprocal before rationalizing. So it's the square root of 3. All right. So we've already talked about these now, but refresher, angle of elevation is the angle from straight out, the angle you'd have to tip your head upward. Angle of depression is from straight out, the angle you'd have to tip your head downward. So a surveyor is standing 115 feet from the base of the Washington Monument. The surveyor measures the angle of elevation to be 78.3 degrees. How tall is the Washington Monument? We have our picture already drawn for us. It gives us our angle of 78.3. It gives us our adjacent side of 115. We are looking for our opposite side. So that means we are using tangent. O and A mean tangent. Tangent of 78.3 degrees equals opposite, which this picture labeled as Y, over adjacent, which is 115. Remember that to solve this, we just multiply by 115 on both sides, and then grab our calculator. 115 times the tangent of 78.3. Make sure you are in degree mode. We get 555.314 feet. And after a little light research, you can find that this is actually pretty darn close to accurate. And one final problem, a 10-foot ladder leans against the side of a house. The ladder makes an angle of 60 degrees with the ground. How far up the side of the house does the ladder reach? So, my little picture here. Here's my house. I got a ladder and the ground. 60 degrees with the ground. The ladder is 10 feet, so there's my ladder. I want to know how far up the side of the house. Well, my x is the opposite. My 10 is the hypotenuse. O and H tell me to use sine of 60 degrees equals opposite over hypotenuse. All right, now we multiply the 10 over. So x will be 10 times the sine of 60. Type it in my calculator, I get 8.660 feet up the side of the house. And your assignment will be page 284. Next class we will review a little and then have another quiz.